Hi, welcome back to another problem. Let's begin. The antenna tracks the autonomous drone, which flies at a speed of u in the x direction. Write out the expression for the drone's velocity in terms of spherical coordinates. And we also have a hint here, pay special attention to the direction. Okay, so if we remember, spherical, I hope I spelled that right, coordinates deal with, we have a big R, which is our radial direction, theta, and then we also have this pitch angle phi. So just to make it a little bit more clear in our drawing here, we're going to have something like R here, and then we have phi and theta already drawn out. Okay? So how do we want to approach this? And this problem just boils down to, are you comfortable with vector decomposition? We are given u, which is in rectangular coordinates, x, y, and z. In this case, it's purely in the x direction. And we want to decompose it into r, theta, and phi. And the way that we're going to do this is with velocity triangles. So, let's draw out what I know. I'll draw a little coordinate system here. And we'll call that y and x. And that's the positive y and positive x. Okay? If we are looking down in our plane in this problem, so if you can imagine orienting yourself above and looking down into the xy plane, we see that we have this position here traced out in the xy plane, which corresponds to the projection of the drone down to the xy plane. And if we're going to draw that out, we can call this little r. And that corresponds to some spot in the x direction and then some spot in the y direction. I think I said that backwards. Corresponds to some point in the y and x, but I think you get the point. And we can describe that with theta. So if we translate that into our velocity equation, or if we have some point here, we know that we can get it like that. This is what we are working with right now. But we know that our velocity is only pointing in the x direction. I'll call that u. Okay? So how are we going to decompose it into r and theta? Well, you got to remember, if we're going to decompose u, we want to decompose it into a new orthogonal coordinate system. So we have to have another axis that is orthogonal to r. And so if we're going to do that, we already defined our r direction. And maybe if I draw this a little with a straight line, ooh, that was pretty bad. I'll try that one more time. Oh, didn't mean to do that. And all my controls are getting mixed up. I apologize for that. We move that down. Okay. Hopefully we won't have any more issues now. There we go. I apologize for that. We can draw our other system orthogonal. Jeez, that's really bad. Okay, we'll do away without the box. We can draw our other coordinate system as e theta and er, so that's our two coordinate directions, and that way we can decompose u properly. So maybe just to clean it up, I'll redraw what we have. So we got positive y, positive x, positive little r, and positive theta. There we go. Just to make that a little more clear. And finally, we got u. Change a different color. And we want to decompose u into r and theta. So from vector addition, head to tail, we got some component in the r direction some component in the theta direction. And then just to extend u out a little bit more so it looks better. And we have u. So u is equal to Vr plus V theta by simple vector addition. And I'll write that out just to make that clear. And there we go. So what angle do we have in here? Well, we said it was theta, right? So we'll just plug in theta there. And so now we can just write Vr is going to be equal to u cosine theta, and V theta is going to be equal to u sine theta. But what's wrong with this, though? What's wrong with V theta? Well, if we said positive theta direction was pointing upwards towards the fourth quadrant, and we drew V theta as obtaining u by pointing in the opposite direction, we have to account for that minus sign. So really V theta is going to be negative u sine theta. Now I'll just circle these guys real quick just so we can get those values solidified. Now we're still not done. We have to decompose it into big R and big theta. So if we go back to our problem here, we have big R, or did I say big theta? I meant phi. My bad. And yeah, so we have big R and we have little r, but we now know V of little r, right? So we have this value here, and we want to decompose it into something like big R, and then we have perhaps a phi direction that we're going to draw in. So following a very similar process to what we just did, we can do something like, if we look at our picture, this is Z, okay? We'll draw that out again, and then we'll draw R, and because we want that orthogonal coordinate system, we have R positive, Z, little r, and then phi. And we know VR is pointing in that direction, or V little r, excuse me. Right? That matches our intuition that we had from before. And so what angle is right here? That's just going to be phi, right? Right there, it matches up with our picture. And so following a very similar process from above, if we want to decompose V little r into the big R and phi, we're just going to do our vector addition like we did before. We have a component in the big R direction, a component in the phi direction, and therefore we can write that V big R, there we go, is going to be equal to VR cosine phi, and V phi is going to be equal to VR sine phi. Similar story as before, we defined positive phi in being in the opposite direction that V phi is pointing in. So really, that's going to be negative VR sine phi. And so now we're just going to plug in our values for VR above. So we have V big R is going to be equal to U cosine theta cosine phi. V theta is going to be equal to negative U sine theta, and V phi, plugging in for VR, is just going to be, let's see here, U cosine theta. I just want to make sure I got my signs correct. Okay. Plugging in for VR, we're going to have negative you yeah, yep, okay. Let me just make that a little bit more clear. So we have negative VR u cosine theta sine phi. And there we go. That is our answer right here. So I hope this problem was helpful. Like I said, I found it difficult at first to get my vector decompositions straight, but it's a skill you're going to have when solving problems like this, and I hope this video was helpful in elucidating or how we will decompose vectors into different coordinate systems. Thank you.